supposed to find the angle measure of each of these angles. So we have 4 possible angles that we can find the angle measure of. So we have also 3 variables on the board. So which variables or which angles do you think would probably be the easiest to start off with trying to find a way to solve them?
The middle two.
The top one and the bottom one, because they both have an x in them. So they're both related to each other somehow. If we can get that x, then that will help us get either the y or the z. So let's start with those. So thinking about this, with this intersection here, of those 2 lines, what type of angle pair is formed by these 2?
What they're talking about?
What's the name of the angle pair? It's a vertical angle. So they make the So we have vertical angles. So that top 20x and that bottom 10x plus 50 makes vertical angles. What do we know about vertical angles to help us solve this?
They all equal.
So yesterday we talked about 4 types of angle pairs: complementary added up to 90, supplementary added up to 180, adjacent, which is sort of 2 angles next to each other, and then vertical angles. What do we remember of vertical angles?
They're the same.
They're the same. So this 20x is going to be the same as 10x plus 50. So if we were to think about that as an equation, we know that 20x is equal or congruent to 10x plus 50. So their angle measures will always be the same because they're vertical. That works for any time you find vertical angles. We proved that yesterday. Can we solve this?
Yeah, you got to minus the 50, then do the same for the other side, and divide by 10 and do the
In my lifetime.
What was your question?
What was the one that you, like what I did was took each one, like we did yesterday, and it equaled 180.
So that was if it was supplementary. So if we had a supplementary where they formed a line, such as 20x and z, they form one line.
Oh.
So if you would do 20x plus z equals 180 because they're supplementary pair. But because there are 2 variables in there, we can't really solve that problem at this moment.
Okay.
So let's focus on this one for now. So we need to get all of our x's on one side and all our constants on the other. So we need to get that 10x to the other side. So I'm going to subtract 10x. So 20x minus 10x, that leaves me with just 10x again. And that's x. And that equals 50. Now in order to solve for this, I need to get that x by itself. So I need to get rid of that 10. So I'm going to divide by 10 because it's currently being multiplied. Divide by 10, and x equals 5. So now that I have x solved for, what should I do with it?
Plug it in, plug it back.
I can plug it back into my problem. So I'm going to take x, I'm going to plug it in for my 20x here. So x equals 5, that's now 20 times 5
100.
is 100. Good. So we know that it's 100 degrees. So if this top is 100 degrees, what else does that tell me?
At the bottom, 100 degrees.
This bottom vertical angle also has to be 100 degrees as well, just because they're vertical, just like we said, they're equal to each other. Okay. Can we try to find z or y now?
Well, we get that 360, then 100, and 100, that's 200, and the other 2, and the rest is what, 360 and 500.
Alright, so you could think of this whole thing as 360 degrees around, and these two are 200 together. What does that leave left over with?
160 divided by 2 is
160 divided by 2 is 80, so that would make this 80 and this 80. Good. Another way of thinking about this is these are linear angles, or they're supplementary, so they add together to equal 180. So 100 plus 80 has to equal 180. So that's another way you could solve for z or y or so on and so forth. If you can get it, you can get it. Just remember, you need to know when you thought of that method, that 360, you have to know that these need to be equal to each other as well in order to divide by 2. Because if they weren't equal, then one might be 90 degrees and one might be 70 degrees. But in this case, we knew that they were equal because they were vertical.
And then they have the same size on the other side.
Yeah. So in this situation, it worked out. So that works. Just remember, you always need just if ever came around a situation where they weren't equal or something, you try that method, it might not be the right answer. But for this situation, you're fine. All right. So we talked about angle pairs yesterday. We talked about complementary, supplementary, vertical angles. So we're going to continue talking about angle pairs, but we're going to talk about angle pairs that are formed from parallel lines. And so this may have been something you learned in 7th grade math. What? Well, that's why we're learning it again today. So maybe it's something you remember before, it might not be something you remember, so we'll just dive in and find out. So when I say the word parallel, what does that mean to you? Never touch or never intersect. So you have two lines that are going at that same distance, that same rate of change, or that same slope. And so the distance between them is never changing. It's never getting closer, it's never getting farther away. They're just staying constant between each other, and they'll keep going on and on and on and never intersect. So sometimes we have parallel lines, and then we get another line that crosses through that. We call that line that crosses through the transversal. So this is a set of parallel lines cut by a transversal. So I'll keep using that word transversal when we're talking about certain angles. Just some vocab to think of. All right, now how many angles did I form by having this set of parallel lines in my transversal? 8. Wow. I got 1, 2, 3, 4, 5, 6, 7, 8. We have a lot of angles. And so as we go through this lesson, I'm going to start writing these numbers sort of just to denote the location of the angles. The location or the numbers don't necessarily matter in what order you write them in. It's just sort of to help us when I talk about angle 1, I'm talking about that. Or when I say angle 8, I'm talking about that one. But that doesn't necessarily measure the degrees of them or represent anything else besides just what location I'm talking about. So just for future notice. So we have 1, 2, 3, 4. My parallel lines just sort of got rotated a little bit, but it's still the same parallel line. 2 parallel lines, cut by transversal, same thing. Doesn't matter which angles we have. We have all 8 of them. Now, if we think about these parallel lines, they're basically like the same thing, just cut in 2 spots. I have a single line that cuts through 2 identical lines. So I basically have those same 4 quadrants in 2 locations. One with my 1, 2, 3, 4, and another with my 5, 6, 7, 8. Now, when you think of the word corresponding, if I were to say, which angle do you think corresponds to 1 from my second group, which angle would you say?
5.
Morgan, why did you say 5?
Because they're kind of both in the same spot, they're just on the left.
So they're both on that like top left quadrant, and so is 5. Colton, why did you say 6?
Because like they're both on the outside of the line and above the
Okay, so you sort of thought of it as like a reflection.
Yeah.
So when we deal with corresponding angles, we're going to deal with how Morgan and Amanda thought and how they're both in like that top left quadrant. It was good to see that reflection in there, but think of it more as a translation. So if you were to slide this parallel line or these like intersections on top of each other, 1 would fall on top of 5. And so we're going to call these corresponding angles. So 1 is going to correspond with 5. Which angle would correspond with 6? I said that. I'm sorry. Which angle would correspond with 2 is 6? Which angle would correspond with 3?
7.
And then that leaves us 4 and 8. So these are our corresponding angles. So they sort of match to each other. And this will be the most common angle pair that we'll use are these corresponding. Now just taking a guess, just looking at them visually, what could you say is the relationship between 1 and 5? They're the same? Why? What do you think so?
They're interchangeably parallel.
In parallel, they just look the same. They look roughly about the same thing. Unfortunately, we can't prove that they're the same without having to pull out a protractor and having to set something up and figure all that is. And so, because we can't prove it, this is called a postulate. So in mathematics, we run into things called postulates and theorems. So a postulate is something we can't prove. A theorem is something you can prove. So in the past, you ran into the Pythagorean theorem. That's something people have proven is true, and so it works. As long as these requirements are met, this will always be true. Yesterday, we proved vertical angle theorem. So we saw as long as we have those intersections of those 2 lines, those opposite angles will always be equal. We proved that yesterday. Unfortunately, we can't prove that corresponding angles are always congruent. They just happen. There's no way for us to like mathematically show it besides actually having to get a ruler and things like that or a protractor. But we can just accept that it will always be true. As long as you have these 2 lines, as long as you have lines that are parallel, then your corresponding angles are always congruent. So they'll always be the same. So 1 will always be equal to 5. 2 will always be equal to 6. 3 will always be equal to 7. 4 will always be equal to 8. That will be true no matter what, as long as those lines are parallel. Now, if those lines aren't parallel, then those numbers will start to vary. And that's something we'll look into next week when we start proving whether these lines are parallel or not based off the information we learned today. But that won't be till next week. So now we've learned about a new group of angle pairs. We now know about corresponding angles. But the thing is, now we know about corresponding angles and vertical angles, we can sort of make a couple other inferences or a couple other relationships and start to form. So if I look at angle 1, using your knowledge of corresponding angles and vertical angles, what are all the other angles that are congruent to angle 1? So what is angle 1 equal to? 4. Why is it equal to 4? So these two are vertical, so that works. Okay. Why is it equal to 8? So 4 and 8 correspond, so these are equal to each other. So if 1 is equal to 4 and 4 is equal to 8, then 1 has to equal to 8. 5? Yep. So 1 and 5 are corresponding. So 1 is equal to 5. And so all 4 of these angles, as long as those lines are parallel, based off of our knowledge of vertical angles and corresponding angles, these should always match. They should always be the same. These locations, 1, 4, 5, 8. Can we do the same thing with 3? What's 3? 7. So 7 and 3 correspond. Good. What else?
6.
6. So 7 and 6 are vertical, so we know those are equal. And then 2, because 3 and 2 are vertical. So all 3 of these are always equal as well. And so when we run into situations, we should always have 1, 4, 5, and 8 are equal, and 3, 7, 6, and 2. Those locations will always be equal. Now, do I see any relationships between 1 and 3? Do I know anything about these two? What was that, Gage? They'll add up to equal 180. They form a line, so we know they'll be supplementary. They're adding to equal 180. So if 1 and 3 add up to equal 180, can I make any inferences about, say, 4 and 2?
Yeah.
What? They're also 180. What about 6 and 3? Oh, no, that's not a good combination. 6 and 1. Can I make any comments or any ideas about 6 and 1? Why are they also 180? It's the same as 5 and 6, or it's the same as 1 and 3. Like, all those combinations, if you take one of each of them, you know adding together, they'll always equal 180. Because these will always be part of it, and this will always be part of it. The supplementary angles will always work out. And so we have now a lot of information that we just formed using our supplementary angles and our complementary, or not complementary, supplementary angles, our corresponding angles, our vertical angles. We sort of formed all this information. But rather than having to memorize that locations 1, 4, 8, and 5, or 3, 7, 6, and 2 are all the same, and then a pair of each of them will work out, rather than having to make that memorization, we mathematicians made some angle pairs that are located on just picking 2 angles and seeing where they're located. And we sort of formed some new angle pairs to help us memorize this information and help us keep this information straight. Rather than having to think that 1 is the same as 4, which is the same as 8, which is the same as 5, we're sort of making a jump. That way we can think of 1 and 8 are the same automatically, rather than having to think it's sort of a progression. We're sort of making some shortcuts with these new angle pairs. Oh, what do I got? Am I recording twice? That's that one. Okay, we're good. We're good. So we'll keep going. All right. So we're going to get 4 new sort of angle words or angle pairs that we're going to talk about. So I'm on parallel lines, up on my transversal. I have all my 4 locations. So we talked about corresponding angles and why they're congruent. That was our corresponding angle postulate. So we already said that pairs 1 and 5 are the same. 2 and 6 are corresponding angles. 3 and 7 are corresponding angles, and then 4 and 8. Those are our corresponding angles we talked about before. So those ones are always congruent. Once again, congruent means the same. They're equal to each other. They're the same angle measure. Then we have three others. We have alternate exterior, alternate interior, and consecutive. When I say the word alternate, what does that make you think of? Opposite. So when I say the word alternate, or when we talk about alternate exterior or alternate interior, what we're talking about is these angles are going to be on opposite sides of your transversal. One will be on the left, one will be on the right. One will be on the left, one will be on the right. They're always going to be opposite sides. That's that alternate word. When I use the word exterior, what does that make you think of?
Outside.
Outside. So we're going to talk about angles that are outside of these parallel lines. So alternate exterior, opposite sides, outside. What's going to be the alternate exterior angle to 1? 8. So 1 is on one side of my, or it's outside my parallel lines, and on one side of my transversal. So I go to the other side of my transversal and outside, which is 8. Right. So 1 and 8 is a combination. Do you see any other combinations of alternate exteriors? 2 and 7. So alternate exterior angles, if we related it back to corresponding angles and vertical angles, these will always be congruent, but we already proved that. So these are your pairs of alternate exteriors, these locations. Outside, opposite sides. Same idea, except now we're going alternate interior. So we're going to be looking at the angles on the inside. So 5 and 4 and 6 and 3. These are our alternate interior angles. And so once again, alternate interior angles are congruent. So anytime you have angles, these two angles, you know they'll always be equal. These two angles will always be equal. No. No, I could do 4 and 5 or 3 and 6 or 6 and 3. It doesn't matter which one. You know they're equal, so you can switch it back and forth. Same thing. So these are the ones that are always equal. Our last group that we're going to have is not necessarily congruent anymore. They're going to add up to equal 180. So they're going to be supplementary angles. And so we call them consecutive. So consecutive, once again, sort of means like side by side. Another way of writing these consecutive angles that I've seen some mathematicians do is they call them same side interior. So if you had to guess based off that information of what same side interior means, what would be your combination?
3 and 5.
3 and 5, 6 and 4, 4 and 6. So same side interiors, they're on the same side of the transversal inside your parallel lines. Interior. So knowing these two angles, they will always add up to 180 degrees. As long as your lines are parallel, these will always add up to 180 degrees. All of this information should always, always, always work as long as those lines are parallel. And so next week we'll see, given some of this information, are those lines parallel because of, does this information work out? You could extend it even farther and think one more step and make one more group of same side exterior angles, and those are also supplementary, but those can also fall under your consecutive. You could also think 1 and 7 are supplementary, 2 and 8 are supplementary, but we don't really use those ones as often as your other groups. Now, of course, this doesn't relate every single angle pair, like 1 and 6, we don't have a relationship for, like 7 and 4, we don't have a relationship for, but we can quickly make those using these shortcuts. Corresponding angles, alternate exterior, alternate interior, supplementary pairs, and we can figure out what every other angle is, even if we just know one piece of information. And so this makes it very helpful when solving for those missing angles in problems. Do you have any questions over this tomorrow? Throughout the rest of the week, we'll take time to practice these and sort of nail some of these down. But what I found the easiest way to do it is just sort of work with them and just keep remembering, reviewing, and keep working with them and keep like noticing, okay, these are alternate exterior, these are alternate interior, these are corresponding. And just sort of repetition of sort of getting them back here. And that will really help with next week when we start needing to write these down and remembering which ones are which. So we have two sets of parallel lines cut by transversals. So look at this first one. I have 50 degrees down on my right, bottom right, and then I have 1 that's representing sort of my missing angle. It's not necessarily 1 degree, it's just sort of whatever I'm solving for. So I can put an X in there. So I need to figure out what is that degree, or what is the angle measure of that missing angle. And there's hundreds of ways, maybe not hundreds, but there's tons of ways we can solve this and figure this out. So your way might not necessarily be the same as another student's way of figuring out, or relationships that they wrote down, but they should all end eventually work out. So how can we figure out what that x is? What are your thoughts using that information we just talked about on that last page? Okay. Okay, so we see these are vertical angles, so 50 and this spot right here. So we know this is also going to be a vertical. I'm going to write that in a better color. Put that in blue. Okay. So we said those were vertical angles. So I'm going to write down my steps, just because that will be beneficial to us next week. I'm going to start having to write down all of the steps. Those are vertical angles. What type of pair are these?
Alternate interior. Oh, right? No.
So alternate means opposite sides of transversal.
Oh.
So they're on the same
It
side
was
of
the
our
last one
transversal.
on the thing,
It was our last one, which is going to be consecutive. So consecutive was the same as that same side interior. And so we can say because they're consecutive, we know that these two add up to 180 degrees. So what number plus 50 adds up to 180 degrees?
130.
130. So we know x must be 130 degrees. Using our... All right, same thing with the other one. We have 100 degrees up here, and we need to solve for this missing angle down at the bottom. What do we do? What? 80? How do you know?
Vertical or then I don't know what's
100 degrees is the
consecutive and vertical.
So these two are consecutive, so you saw this one had to add up to 180 degrees. So that made this one 80, and then so these ones are vertical, or vertical and then consecutive. It doesn't matter which way you do it. Okay. So you use the same two rules you did last time, consecutive and
Which
vertical.
ones are consecutive?
Your consecutive angles, once again, your same side interior. So 100 and whatever this angle is down here was consecutive. So based off that information, you could solve that this one is 80, because you know they have to add to equal to 180. And then these two are vertical, so you know this one will have to be 80 as well. Another way of thinking is, this is vertical, so this also has to be x. And if you can solve that for 80, this has to be 80. It's the same logic, the same. Can anyone think of another way of solving either of these? Using different angle pairs rather than consecutive or vertical? So 50 is the same as this angle up here. That's called alternate exterior. They're alternating sides of my transversal. They're outside. So these are alternate exterior, so I know they're the same. These are a linear pair supplementary, so I could solve that to be 130. That's another way of doing it. Once again, there's hundreds of ways. This one, I could think, okay, 100 corresponds to, this is 100. So these are corresponding angles. Corresponding angles and then supplementary makes us 80. So once again, it doesn't necessarily matter which way you go about solving it, just as long as you have that method, you know your angle pairs, you know what rules you're using to get there. Are we okay with this? Okay. So we're going to step it up just one level. Rather than having a missing angle, we're going to try to figure out what x is. So we need to figure out how can we find a relationship between those two spots, or make some new relationships by moving some stuff around, writing down some more information, and then how can we solve for x? So what can we do to help figure out what x is in that first one? So alternate exterior would relate these two. I assume that's what you mean, right? So this is 110 down here. And now these two are, I'm going to write alternate exterior angles. Help us remember that. That's what we did first. And then these two are supplementary. So I'll write sup, so that we have a supplementary. So we know, what does supplementary mean again? Adds up to 180. So 180 is equal to x plus 20 plus 110. Can we solve this? So 20 plus 110 equals 30. What was that? Oh, sorry. And x equals, we did it. And you can then solve for your angle by adding it and getting 70. I think we just have to solve for this. Is that okay with how we got that one? What about your second one? Can you think of a way that we can do this?
Aren't they the same?
Wow. So we know they're the same. We just have to think what rule we're using to get that.
I don't know the rules for it.
So you could do it in a couple ways. Probably the easiest one. These two are in those same quadrants. If we think about them as those four quadrants, they're both in that fourth quadrant. So when they fall in those same quadrants, we call those corresponding. Good. So we have corresponding angles. So because they're corresponding, we know they must be the same. We know they have to be equal to each other. So we know 3x minus 20 equals 70. You can go through solving it this way. Add your 20. That gives us 3x equals 90. Divide by 3. And we get x equals 30. Another way, this is the easiest way, is just realizing these are corresponding angles. If you didn't realize that, you might think, okay, these are vertical, so this is 3x minus 20. These are same side exterior, or this, not same side exterior, alternate exterior angles. And so that's another way of solving it. But once again, there's tons of different ways you can figure these out, tons of different ways we can solve these. It doesn't necessarily matter which one you do, it's just as long as you can get those angles down. And once again, tomorrow and Thursday, we'll continue to practice these, continue to get those names down so we can start writing those rules and how we know they're right. Because that's just as important as being able to solve them, it's knowing why you're able to solve them. So I have a little bit of practice for you that you can work on till the end of the period that can help you practice solving them and practice using these